Hi, my name is Erica Kleinman, and I'm a PhD candidate at UC Santa Cruz. I'm here to present the paper, What Else Can I Do? Examining the Impact of Community Data on Adaptation and Quality of Reflection in an Educational Game. This is a paper I worked on in collaboration with Jennifer Villareale of Drexel University, Murtuza Shergadwala, Zhaoqing Teng, Andy Bryant of UCSC, Jichen of IT University of Copenhagen, and Magy Seif El-Nasr, also of UCSC. Diving right into it, educational games are seeing increased use in classrooms thanks to empirical findings that prove their value as learning tools. But with their increased use come a number of emerging questions about how to ensure they effectively support learning and actually lead to knowledge gains. Learning is comprised of many factors, but one element that is underexplored within the domain of educational games is the concept of adaptation, which refers specifically to making adjustments to one's approach, usually based on reflective processes. For example, a student playing a learning puzzle game may initially attempt a brute force approach, trying every option they have until they find the right one. Upon failing, however, they may reflect on what they've done and then perhaps try the game again, adapting their approach, instead examining all the available clues to determine what the right solution is. Learning literature has demonstrated how consideration of alternative solutions in this way can help learners better understand a topic and achieve success in a learning environment, and has explored the use of data visualization systems, often referred to as either open learner models or learning analytics dashboards, as a way to prompt adaptation by exposing students to community data, i.e., data about how they are performing compared to their peers or classmates. Similar systems exist in games, but they're not commonly seen within the domain of educational games. Instead, they're commonly implemented and used in domains such as esports. In educational games, traditional prompting has been the primary means of eliciting reflection and adaptation, and visualization as a concept is less explored. As such, there exist a number of open problems and unanswered questions regarding the impact of pure data on adaptation in an educational game context. Therefore, in this work, we set out to explore this topic and address this gap by answering two primary research questions. First, does comparison with peer data impact a player's willingness to consider a different approach? And second, does comparison with peer data impact a player's quality of reflection, which we're concerned about because previous work has shown that knowing one is at the bottom of the ladder can actually lead to poor quality reflection, discouragement, and ultimately discontinuation of play. To answer these questions, we conducted a repeated measures study using the game Parallel, which uses visual puzzles to teach parallel programming concepts to computer science students. Specifically, we used Parallels Level 7, pictured here. While a full tutorial of how to play the game is beyond the scope of this presentation, essentially each of these arrows represents a thread in parallel programming, and when the player hits Test or Submit, they will move along their designated tracks, pick up packages, and attempt to deliver them to the delivery points. The player's goal is to place semaphores and signals on the track to control the movement of the arrows so they don't attempt to pick up packages at the same time and then ultimately fail to deliver them. We chose parallel for this study as each level has multiple possible solutions of varying degrees of efficiency and correctness, and specifically we chose level 7 because it was simple enough to not be overwhelming, but complicated enough to present a bit of a challenge, thus warranting some level of reflection and adaptation from players. So our repeated measures study proceeded as follows. First, we recruited 36 students from computer science undergraduate courses at UCSC, Drexel, and Northeastern University. We introduced them to Parallel through its 5-level tutorial, and we then had them play level 7 twice, a few days apart from each other. We then had them look at visualizations of their own gameplay process in the context of two other students' gameplay processes. We refer to this as peer reflection, and this is what the visualization in this step looked like. Essentially, the player had a visualization of their own gameplay in the middle and visualizations of two other players, a similar player and a different player on either side, and they were told which one was which, as you can see here. For this study, gameplay was visualized in a process-oriented manner, with each node in the timeline you see here representing an action the player took. Each node is also accompanied by a snapshot of the board state at that moment to provide context, and players were also provided with this key you see at the top for how the board was broken down into sections to help them understand the labels for the nodes. Similarity was determined between two different play traces using a dynamic time warping algorithm, and more details are presented on this in the paper. While looking at these visualizations, players were first asked to describe the gameplay in each playthrough based on the sequence, which was meant to force them to read it to ensure that they did actually look at it. They were then asked the questions you see on the slide, where they were asked to say what went well in their playthrough compared to the others, what went poorly in the playthrough compared to the others, and if they were to play the level again, if they would do anything differently. The first two questions were open answer, and the third was answered with a yes or a no. Following this step, the players were then shown a visualization of only their own gameplay and asked the same questions. We referred to this as solo reflection, and it looked like this. The visualizations use the same style, but this time the player is only shown their own two gameplay attempts at level 7. They were once again asked to describe the gameplay in both attempts based on the visualization, and then asked the questions you see on the right, where they were asked to say what went well in their first attempt compared to their second, what went poorly in their first attempt compared to their second, and if they would do anything differently were they to play the level again. And for clarification, to ensure that the order of exposure to peer or solo data would not impact the results, only half the group reflected in the order I just described, while the other half reflected in the opposite order, looking at their solo data first and then their peer data. For data analysis, the qualitative open responses were coded using Lejeune et al.'s framework for measuring the quality of reflection based on the focus and level of reflection. The applied codes and the yes-no answers were tallied up, and significant differences were determined using McNamara-Bowker tests, and effect sizes were calculated with Kramer's V. Inter-rater reliability was also used when coding the qualitative data, and more details are presented in the paper. Now on to the results. Our primary result is that players were willing to consider a different approach significantly more often after reflecting in the context of others' data. For more details, only 2 players said that they would consider a different approach if they were to play the level again after reflecting in the solo condition, versus 12 who said they would do so after peer reflection. The p-value for this measure was 0.004, and the effect size according to Kramer's V was 0.5, indicating a large effect size. Additionally, there was no significant impact on the quality of reflection, meaning that seeing the data of others did not lead to lower quality reflection or discourage players, which is ultimately a promising finding. Based on these results, we present a couple of implications for future work. First off, regarding prompting adaptation, we argue that developers of future educational games and support systems for learning should consider leveraging comparison with peer data as a way to motivate adaptation, but remain open to alternative techniques as well, seeing as only about 1/3 of our participants were actually motivated to adapt via this method, suggesting that there are other methods that might be more effective. Based on that, we also present this as an opportunity for future work to explore these alternative ways that adaptation can be prompted. Additionally, we identify some questions for exploration in future work. First, when in relation to the progress and completion of a learning task within an educational game should reflection on community data be prompted? Specifically, should it be prompted while the player is attempting to complete the task or afterwards, as we did here? Or is there another time point we should consider? Second, how do we present community data such that the quote best solution is not exposed in a way that inhibits players' ability to explore and learn naturally, as previous work has shown that when a single correct solution is made apparent, players will tend to just copy it without putting too much thought into it, which can ultimately inhibit learning. Finally, how do we present community data in a social learning context while remaining safe and ethical, as recent work has brought to light concerns regarding the safe and ethical handling of data and how exposing one's data to a community could potentially put one at risk. That concludes this presentation. This work was funded by the NSF, and at this time I can answer any questions.